Let us read the question which was given in JEE Mains 2025 on 24th January shift 1, which says that during the transition of electron from state A to the state C of a Bohr atom, the wavelength of the emitted radiation is 2000 angstroms and it becomes 6000 angstroms when the electron jumps from state B to the state C. Then the wavelength of the radiation emitted during the transition of electrons from state A to the state B is. Let us quickly get into the solution. From the above question, we got to know that the energy difference between A to C, which is equals to 2000 angstroms, and energy difference from B to C, which is equals to 6000 angstroms. All that we need to find is the energy difference between A to energy difference of A to B, which is equals to. That is what we're going to find in this question. From the above question, it is said that there are three states which are A, B, C. And when the electron gets transited from A to C, it emits some radiation which had a wavelength of 2000 angstroms. And when the electron gets transited from B to C, it also emits some radiation which had a wavelength of 6000 angstroms. The question is that we have to find the wavelength when the electron gets emitted or transited from A to B, and then it also gets emitted some radiation. This radiation's wavelength is that we need to find. We all know that from the Bohr's postulates, which is equals to delta E, which is the energy difference, is always an integral multiple of h mu. Therefore, from this postulate, we are going to find the wavelength of the radiation emitted. EA minus EC is equals to h into mu can be written as C by lambda. EA minus EC, which is equals to h into C by lambda, is 2000 angstroms. In the case of the electron gets transited from state A to the state C. Let it be equation 1. Coming to the next part, it is also given that energy difference between B to C is equals to h into C by lambda. In this case is 6000 angstroms. Let it be equation 2. Subtracting equation 1 2 and equation 2. Subtracting equation 1 and equation 2. We get EA minus EC minus EB minus EC is equals to HC by 2000 minus HC by 6000. EA minus EC minus EB plus EC is equals to, taking HC by 1000 as common term, we got 1 by 2 minus 1 by 6. Plus EC minus EC gets cancelled, and net we will get the EA minus EB. That is equals to HC by 1000 into 6 minus 2 by 12, which is equals to EA minus EB is equals to HC by 1000 into 4 by 12, which is 3. EA minus EB is equals to HC by 3000 angstroms. Comparing this equation 3 with the fundamental formula which we had, delta E is equals to hc by lambda. We had 3000 in the case of lambda here. Therefore, the wavelength is equals to 3000 angstroms, which is the required answer for the above question. From the solution itself, we can conclude that 3000 is the given answer for the question, which matches with option C.